Hi guys, today I will create a project in TIA portal with S7 1500 CPU. So let's start. I'm opening the TIA portal software which I have installed earlier. So here is the open existing project button, and when you click on it, it will show the existing previously open project in right window. If you want to create a new project, you have to click on this button. If you want to migrate the project from earlier version of TIA, you can click on this button. Or if you have the project of Semantic Manager for S7 300 400 CPU, you can migrate that project to TI portal project. So I to migrate Semantic Manager project to TI portal project, you have to install Semantic Manager in your PC. This Semantic Manager. So now I am not migrate the project. I am creating a new project. So click on the create new project. You can give a project name, test project, test project, and location will be this. You can change the path and you can change the author name also. So then click on the next button. Now project is created, but in this project there is no device like HMI, PLC, CPU, no, nothing. Just it created project file. So you can do by two way. You can go to project view, or you can click on the this button, device and network, configure device. You can do in both way. So I am going to project view. So it is showing like this. So I am click on the device and network. Device and network. See, there is nothing. There is nothing showing because you have no device. So to add the device, you have to click new, add new device. So which type of device you want to add? Controller, HMI, or PC system. PC system is SCADA system, or HMI, touch skin system. So I want to add the PLC CPU. So I am click on the controller, and it's showing this catalog: Symmetric S7 200 PLC, Symmetric S7 1500, Symmetric S7 300 400. So in TIA portal you can configure S7 300 400 PLC also. So I want to add S7 1500 CPU. So click on the S7 1500, then click on the CPU. See, there is lot of CPU. There are three types of CPU actually. One is standard CPU, another is compact CPU, which name as right side C, and another is fail safe CPU. fail-safe CPU. So fail-safe CPU also is the technology CPU. Also is the technology CPU. So which type of CPU you want to add, you have to know this as your application. You have to know first that the CPU function. The CPU, general CPU, standard CPU, it has the general function. That means uh, it has no technology function, that PWM output, counter, like this. This is technology. This this function can be found in technology CPU. Also, some CPU, fail-safe CPU, has a technology function. Has a technology function. But and this is a compact CPU. Compact CPU means it has integrated I/O, input, digital output, analog output. It has integrated with the CPU. Mm, like for 16 input, 16 output, 2 or 4 input, 4 output of analog, like this. So if I want to take the 1500 13F, F means is fail safe. Fail safe means it has the safety function. Standard user program you can create, or safety program also you can create in the same PLC CPU. No other safety CPU need externally. And this safety function, safety module, input output module can be added in centrally or decentrally in field. So I want to take the fail-safe CPU, and fail-safe CPU mark as a yellow, and general CPU mark as a green, like this. Oh, like blue actually. Okay. So I am taking this because I want to show how the function of PNDP. In this CPU has two Profinet network, one is Ethernet network, and this port separate. This middle two port is the same network port. You can use this port as a star connection. Also you can use it as a ring connection, and this is a second port and second network. So I am click on next OK button, and it will add the PLC CPU, and it will appear here. Just wait. Yes, this is appear here in a rail, universal rail 0. It is called actually universal rack in, and this rail, we have CPU is in position 1. You can add the input output device, input output module in slot 2, 3, 4, 5, 7, like this. Okay, up to 31. To 31 we can add in rail 0. Or if you want to add the the module, see, input output module separately, like with the distributed module ET2000S, you can do this. So this way you can add the PLC. Now you have to configure the PLC properties. There are lot of properties, lot of configuration in the PLC, but only you have to configure some major configuration that you need. That one is failsafe, pre-activate parameter, a parameter. So keep it as it is as default. You can change it as your own, but you can keep it as a standard, because Siemens make it default with lot of analysis. You can choose your own way. This is failsafe address can be written from 1 to 19. It can take 1 to 19. And now go to profinet interface. We talk that there are two profinet interface. One is X. X has a two port, and this port address, this port IP address is like this: 192.168.0.1. You can change as your requirement, or you can keep it as default. Also, you have to create you have the IP address set here default, but you have no network to add the other device. So you have to create a network. To create a network, you have to click on add new subnet. So click. Now it create with the name PN/IE_1. This is the network name of this port. Second, profinet address. This is name profinet interface 2. This is the second network. You can also change the network address. You can choose another subnet of the network, or you can keep the default addresses. So I am leave as a default subnet and create a second network by clicking on the add subnet button. So it create a second subnet network, PN/IE2. Okay. Second, we have the DP interface in this CPU also. So click on the DP interface. You can write the take the address as your own, or you can keep the address as default to we can take the address from 2 to 168 126 address you can choose, or anyone you can choose. So also this address you will not work until you create the network by clicking that subnet. So you can add the device in this network. So this subnet will show as a Profibus 1. and this CPU act as a TP master. Also, you have to choose the startup condition. This is the startup condition, the when the power on. If the CPU turn on from the stop mode, so how it will act? Suppose if your CPU first it was on, now you turn off and then turn on. So this warm restart dash operating mode before power off, it will uh, turn the it will go run mode as the before power off condition. Also also the warm restart run mode, it will goes to on restart. So keep as it is, no problem. And second one is startup CPU event mismatch. That is called if you configure in your project, mm, you have add like 10 module, but in process in the plant you have add 9 module. So there is a mismatch of one CPU, so it will go to run mode or not. So if you select even if mismatch, so it will go to run mode with a warning alarm. So or if you choose the startup CPU only if it is compatible, so it will go like this. Also mismatch also like this, that you add the CPU 10 module, but in the software you have add 2 DI module, then 1 AI module, then 2 DI module, like this. But physically the AI module is in last position. That time also CPU will goes to run mode with on. And configuration time, this is the 60,000 millisecond, that means 60 seconds. So CPU should go run mode within this 60 seconds. This is the configuration time. Then cycle time, maximum cycle time is 150 millisecond. If your user program execution time exit 150 millisecond, then CPU goes to stop mode. So you have, if your user program is big, then you have to choose your cycle time more than 150, or you have to calculate, you have to check the cycle time by go online, or you can calculate by your own. Communication load, cycle load due to communication, this is 50, here it is 50%. That means when you go online or your device connected, that time communication will add 50%. That means if in the communication maximum cycle time is 150, so 50% communication load, so it is 75 millisecond. So when you communicate with the CPU, so 50% of 150, that means 75 millisecond will add, so it is 2 to 5 millisecond during the communication. It will be, so maximum cycle time considered as a 2 to 25 during the communication. So another important things is system and memory, clock memory. This is a good configuration that it is need in the user program. You don't need to create. You can create in your user program this bit, but in CPU, in Siemens, it is in built-in. You can activate the system and clock memory. So how can we do this? We have to click on the system and clock memory, then to activate the system memory bit, we have to click on the enable use of system memory byte, and if you activate the clock memory bit, you have to click on the enable use clock memory bit. Okay, so or you can change this memory bit 0, and it can this is goes to red because of it already take it. So I am changing to 0 to 1. So this system memory, what bit is there? This is a first cycle. When CPU turn from off to on and CPU goes to run mode, and it will execute the user program. After the first cycle, first execution of the user program, it will goes high. So it is the first scan. When the first scan is, it will give a pulse, and this M0.2, it will be always high, always high, and this M0.3, it will always low, always low. And this 2 bit very important because it is used in our user program frequently to bypass or add something. And also clock memory is used very frequently. We don't need to create this pulse manually. This is 10 hertz clock, that means 100 millisecond pulse, and this is 5 hertz, that means 200 millisecond pulse. Every 200 interval it will go high then 0, go high then 0, like this. And this is the 1 second pulse, 1 hertz, that means 1 second pulse, 1 second interval pulse. So we can use in the user program for better performance. We don't need to create manually. This is all. You can also create the password for your CPU to protect unauthorized access, or unauthorized access means read, write, everything. You can like this. You can change password, time until automatic log off, or disable anything. So don't need if you don't want to protect your password, program or CPU program. So leave. This is the general configuration. Mostly sometimes you need more things to configure as the application. So this is it. So we don't need to create more, we don't need to configure more. So I am saving it. Okay.